So I know that the rule is x squared minus x minus 12, that's my argument, that's the thing I'm plugging into log, has to be bigger than 0. Lovely thing about finding the domain, again, I'm already comparing to 0, so now I just want to try to factor that left-hand side. So it looks like we need an x and an x. I'm thinking a 4 and a 3 with the 4 negative. Let's double check. That's going to give me plus 3x minus 4x. That gives me my minus x. And there's my minus 12. Excellent. So I'm going to draw myself a number line. I'm going to mark off my boundary points, which would be 4 and negative 3. And then I can just pick some test numbers. I've done a very good job of leaving myself space to work, so I'm going to do that over here instead. That way I can write out my factors, x minus 4, x plus 3, and the overall sign. So to the left of negative 3, let's try negative 4. Negative 4 minus 4 is negative. Negative 4 plus 3 is negative. 2 negatives will give me a positive. Between negative 3 and 4, I'm going to try 0. 0 minus 4 is negative. 0 plus 3 is positive. The product of a negative and a positive is negative. To the right of 4, I'll try 5. 5 minus 4 is positive. 5 plus 3 is positive. Product of two positives is positive. We always want the intervals where the argument is positive, so my domain is going to be the interval from negative infinity to negative 3, union 4 to infinity, parentheses everywhere. All right, excellent. So that's going to give us a nice opportunity to review our polynomial inequalities. Sometimes the argument might involve a square root as well. So let's just take a look at two other functions. Let's say I've got f of x is the log base 2 of the square root of x minus 1. Okay. All right, and I want to compare that to g of x, which is the log base 3 of 1 over the square root of x minus 1 plus 5. Okay. Now, that plus 5 is not part of the argument. Okay. If it were, I'd have to have parentheses here. Okay. Since there are no parentheses, we're adding 5 after we take the log. Okay. All right, so let's start with f of x. Okay. So I need to be able to do two things. I need to be able to plug in to the square root, which tells me that x minus 1 has to be bigger than or equal to 0 in order for the square root to be defined. But then I need to be able to plug that into log. So I need this square root of x minus 1 to be strictly bigger than 0. Now, the fact that it's a square root automatically tells me that it's going to be non-negative. It's going to be bigger than or equal to 0. I just need it to not be 0. So these two things together are going to just change that to a strict inequality. I need x minus 1 to be strictly bigger than 0, because if x minus 1 were equal to 0, I'd be able to do the first step. I'd be able to take the square root, but then I wouldn't be able to plug into the log. Okay. All right, so if x minus 1 is bigger than 0, x just has to be bigger than 1. So my domain would be everything from 1 to infinity. Okay, now for this one, adding 5 doesn't do a thing to change the domain. Okay, if we're adding 5, we're doing that after we take the log. I can add 5 to anything. I'm focusing on this part. I'm taking a square root, I've got some stuff in the denominator, and I'm plugging into log. All three of those things give me some restrictions. Okay, so in order to take the square root, I know that x minus 1 has to be bigger than or equal to 0. But because it's in the denominator, I know I don't want it to be 0, because the square root of 0 would give me a 0. So in order for this to be defined, I need x minus 1 to be bigger than 0. Then that's going to give me something positive, because the square root can only spit out 0 or something positive. We're saying it's not going to spit out 0 because we're making sure that the quantity under the square root isn't 0. So the denominator will be positive, the numerator is positive, and so that takes care of itself. We actually get the same inequality. Okay. In both cases, just to be able to take the square root, x minus 1 had to be bigger than or equal to 0. In both cases, we had to turn that into a strict inequality, but for slightly different reasons. Here, we couldn't have 0 under the radical because that would put 0 in the denominator. Once we took care of that, we were automatically getting something positive so that we could plug into the log. As long as this was defined, it was going to be positive. So the log didn't actually introduce any new restrictions. In this case, the square root would have been defined if x was 1 so that we were getting 0. But because I was plugging into the log, it couldn't be 0. So the reason we go from an inclusive inequality to a strict inequality, here it was because we were plugging into the log, here it was because we had the root in the denominator, but the result is the same. We get this same inequality, x has to be bigger than 1. The domain for both of these functions is everything from 1 to infinity. Okay. So anytime you're calculating the domain of a log function, you're just looking at the argument, that's got to be positive.